In this series of videos, we're going to go through the 5 different types of reactions and figure out if I give you the reactants, you should be able to tell me the products that are being produced when those chemicals react. So the first type of reaction that we're going to predict the products for is decomposition. Now the decomposition, remember, is the breaking down of a compound. Now if you have not gotten out your reference table, please get your reference table out now. Pause the video when you're ready, start the video back. So, decomposition, step 1, and they all have different steps, so that's the hardest part, is knowing when to do what. So once you figure out what type of reaction is, then you go from there. So decomposition, step 1 is compare your reactant to the guidelines. Guidelines are on page 6 of your reference table. And decide which letter it resembles. And in just a second, I'm going to talk about all the different letters and what's happening. Step 2, write the general reaction, which is what's found on page 6 in the guidelines. Replace M with the metal. And then step 4, crisscross charges. This is the most forgotten step, and this is the step that is across the board on all the different types of reactions. You have to remember to crisscross. So on page 6 of your reference table, you should see the 5 different types of reactions with a bunch of letters and a bunch of other stuff that probably looks like a foreign language. Your job is to take the take the reactants that I give you and match it up to the one that looks the most similar to what's happening. So an A, binary compound, means just 2 elements. So if you have a compound that is just 2 elements, you're simply going to break it apart. Now in most cases that is not what is happening, but for whatever reason students think that's what happens all the time, that you just separate things and move on your way, and that is not the case. And then B through E are your polyatomics. So B means that you have a metal attached to CO3. C means HCO3. D, hydroxide. E, chlorate. So you're just simply looking at the polyatomic that's attached. So, number 1, NaClO3. Step 1, compare this to the guidelines and figure out which letter it resembles. So for this one we have a metal and ClO3. So which out of the guidelines has a metal and ClO3 as a reactant? And that is E. So step 2 says to simply take that and write the general reaction. This is the general reaction. MClO3 is going to produce MCl plus O2. So from there, the next step is literally take your metal, which in this case is Na, and replace it over here. So it becomes NaCl plus O2. And then the final step, that is the most forgotten step, is to crisscross charges of your ionic compounds. So NaCl is our ionic compound. Na has a charge of 1, Cl has a charge of 1. When you crisscross, they go away because they're both 1s. So your final answer, NaCl plus O2. Li2CO3. Now if you think you've got this, pause the video and try it on your own. And check your answer in a minute. If you're still hesitant, follow me again. So LiCO3. So which out of the letters has CO3 in its reactant? And that is going to be B. We have a metal and CO3. So that is B. Write the general reaction. MCO3 produces MO plus CO2. Now, again, we're just taking the metal, which is Li I could care less about this too. We do not bring over subscripts, and you might want to write that in your notes, huge, highlight, bold, star, whatever you need to. Do not bring over subscripts unless it's a part of a polyatomic and you need to do so then. So do not bring over subscripts. This too means nothing when it deals with the products. So that means when we write the general reaction over here, MO plus CO2, for this one we're going to have LiO plus CO2. Now we're going to find our new subscripts by step 4, which means we crisscross charges. So Li has a charge of 1, oxygen has a charge of 2. So yes, when you crisscross, Li does end up with a subscript of 2, but not because of this 2 over here, but because of oxygen on this side. We don't have to crisscross charges on CO2 because it's not ionic. It's molecular and the thing's already given to us. Final answer. Now please pause the video and try this one on your own. And check. If there's something you don't understand about this example, please make sure that you make note of it and bring it up in class. Now the next example is an example of A. How do I know it's A? Because you have just 2 elements. It's a binary compound. So this means we're simply going to take AB and split it into A plus B. So the most wrong answer is this, Na plus Cl. Now it looks like it would be right based on the guideline. There's just one slight thing that you've got to remember, and that is we have single elements. We've taken this compound and formed single elements. Now remember, there's 7 elements that cannot stand to be alone, period. So when you take them out of their compound, they're going to find themselves to bond with. Na? No. Cl? Yes. Chlorine is a diatomic. Remember, the diatomics start at 7, make a 7, and there are 7. So whenever you see them by themselves, you must have a subscript of 2. So pause the video and try this one. This should be your final answer. When water breaks up, you get hydrogen and oxygen, both of which are diatomics. So you have to give them the subscripts of 2 because they cannot stand to be alone. This next one, you have to memorize. Okay, I did this as a demo in class. It's just one of those reactions that doesn't quite fit any of the guidelines given, but you do need to know the actual reaction. So this is hydrogen peroxide. This is water. That 2 is not there. A peroxide, oxygen ends up with a subscript of 2, and then whatever's here ends up with a subscript of 2 as well. So when hydrogen peroxide breaks down, it forms water and oxygen gas. So this is one of those, if I give you the reactant as H2O2, you need to memorize that it forms water and oxygen gas. And we will be doing a lot more individual practice on predicting products, and this is 1 out of the 5 for predicting. Decomposition, single replacement, and double replacement are the hardest ones to actually do. The next 2 videos that you watch will be very quick and hopefully easy to understand.